Hey everybody, I just want to share a quick physics experiment I did. I wanted to train a neural network to actually simulate physics. So here we are just running this simulation. It's just bouncing circles with just regular physics in Pygame. But here we have just switched to XGBoost. So every collision here is now is being predicted by XGBoost. You can see it actually just got slower. And here is neural net. So right now, neural net actually seems to work quite fast. XGBoost is slower. Anyway, every one of these interactions is now actually being calculated by this neural net. And here we can go back to the physics, and there's hardly any difference. So essentially, I'm just going to talk quickly about the training, how to train the data. Actually, see, look at the neural net behavior. They're actually bunching up here. If you go back to regular physics, uh, they should disperse. Let's see what will happen with XGBoost. Slower though, because probably the reason for this actually bunching up is that in the training data, which we have quite a lot of, there must be a bias towards bottom left portion. Look, maybe more of the collisions happen that the velocities were heading that way. So yeah, they started bunching up. But if we actually let's reduce the particle count and let's go to XGBoost and see what happens. Let's actually reduce it. Anyway, I'll let this play a little bit to see what will happen. But essentially, I have a collect physics data script. By the way, depending on where you're watching this from, you can access the source code at my Patreon. Link will be below in the description or in the comment. But this collect physics data runs this simulation using regular physics equations and collects the based on the amount of collisions that happen in each frame. Here we are saying, for example, collect collisions from 1,000 frames. When you run this, let me run it separately. Well, actually, when you run it, you get a data set like this of collision outcomes, such as we have 900 some of them. So it's like the position and velocities of the particle, mass, radius, and then the output velocities and positions. And then after that, I have a trained neural network model and trained XGBoost model. And once they're trained, their models will be saved here. And then all you have to do is just run the bouncing circles. And I'll show you something interesting. Yeah, the XGBoost model is actually bunching up on the right hand side, and we just switched to neural network. And there's also the batched inference here, which speeds it up considerably. But when you train it with let's train it on just one data point. So let's run this, and now we have only this many collisions in that single frame. And actually, let's run it again. So maybe we'll get fewer, because sometimes, yeah, look, now we only have two collisions. And then we can train the neural network model, and I'm going to run the XGBoost right after that. So they're going to train back to back. And right after that, now the models are automatically saved. And now we can actually run the bouncing circles. And we can see now, well, how will these physics simulation behave? This is, of course, our regular physics simulation. And here's XGBoost. As you can see, our data must have been biased that way. And if you take a look at some of the collisions, actually, the collisions still seemingly like they look at this too, for example, here. And here is the neural net. Let's actually reset this. So this is the neural net behavior. Look at this. It's crazy. XGBoost seems to have done better. Let's actually rerun this. I think that was due to them having bunched up so much. Neural net should actually behave a little bit better, but not much better than XGBoost. Let's just switch to neural net. No, neural net seems to be actually totally broken. Anyway, but a little bit ago it was working fine, right? If we increase the collect data collection, and then run the training again, one after another, and start the simulation, then we will see that uh, they'll run much better. Anyway, do consider becoming a patron. As a patron, you'll have access to over 500 of my projects, to their source code, plus exclusive videos and weekly meetings with me. So let's switch to neural net, and you can see everything's working fine now. And if we were to run this for a little bit, we may see some biased behavior. I think like they seem to be going towards the right hand side, for example. Let's see what XGBoost is going to do. But I was kind of surprised. I was hoping that what I was hoping to achieve was to get a neural net to actually be faster than the regular physics. And apparently, I mean, at least within this, what I've done wasn't possible. I'll have to think of some hacks. So I'll try to update on this. ChatGPT said this, I probably need more computationally expensive simulation for neural net to be cheaper than just regular physics calculations. Anyway, I hope you enjoy this. And like I said, the project source code will be at Patreon. And see you in the next video.